A leading manufacturer of kitchen appliances advertised its products in two magazines, Good Housekeeping and the Ladies' Home Journal. A survey of 500 customers revealed that 140 learned of its products from Good Housekeeping, 130 learned of its products from the Ladies' Home Journal, and 80 learned of its products from both magazines. What is the probability that a person selected at random from this group saw the manufacturer's advertisement in A, both magazines, B, at least one of the two magazines, or C, exactly one? Now, some of this comes directly from the data they gave us. In other parts, I may have to do some diagrams or use some formulas or things of that nature. But the information I'm given here, I'm going to let G be those who got learned of the products through Good Housekeeping, and that probability is 140 over 500, which is 0.28. The probability of them getting learning of the product through Ladies' Home Journal was 130 out of 500, which is 0.26. And both magazines, based on what they told us, was 80 out of 500, and that's 0.16. So these are pretty self-explanatory from the information that they have. The sometimes when you're going to start seeing the term at least one, or at least this, or at least that. And sometimes you might have to interpret what that means in order to know what probabilities you're going to need to find and eventually calculate to get the answer that you're looking for. The probability of at least one of the two magazines. Now, there's only two magazines mentioned, so basically either they learned the product through Good Housekeeping, Ladies' Home Journal, both, neither, one or the other, that sort of thing. So there's no other magazines mentioned. So when I do the problem, so basically at least one of the two magazines means that I'm looking for the probability that of having either a member of group G or a member of group L. And I'm going to use the formula, the addition formula for the probability of union, and that's going to be the probability of G plus the probability of L minus the probability of both. So as you can see there, I worked it out and got 0.38. The last one is asking the probability of getting it from exactly one magazine. So one or the other, but not both. That's what this one is. That one's a little harder to do. So in this one here, I am going to employ the use of a Venn diagram. So I set my Venn diagram. I have a circle for G, a circle for L. I've worked out these probabilities already. And very importantly, I also worked out, although it's not needed for this, the probability of someone learning of their product not in either of these two magazines, because that might play a role too in some questions. So it's always good to make sure you figure out any and all regions that are in your Venn diagram. But I want to figure out the probability of someone learning of this product through only one magazine. So exactly one, so one or the other, but not both. So I'm looking for basically the probability described by these two regions. And so when I make use of that, that means that the probability of getting exactly one magazine, or that someone learned a product through exactly one magazine, is 0.12 plus 0.10, which equals 0.22. Or about 22% of the respondents learned the product through one magazine or the other, but not both. So for example 6 now, in a survey of 2,140 teachers in a certain metropolitan area, there was basically a survey conducted, and they were asked their opinions about attitudes about teachers. 900 of them said they have a lack of parental support and that that's a problem. 890 said that abused or neglected children are problems in their school. 680 of them said that malnutrition or students' poor health are problems in their school. 120 said that lack of parental support and abused or neglected children are problems. 110 said that the lack of parental support and malnutrition or poor health are problems. And 140 said that abused or neglected children and malnutrition or poor health are problems. And 40 said the lack of parental support, abuse or neglected, and malnutrition or poor health are problems in their school. So all three categories. What is the probability that a teacher selected at random from this group said that lack of parental support is the only problem hampering a student's schooling? So this one has three different groupings, three different, attitudes or, problems that teachers are listing as issues at their school. So, it's not going to be as easily as some of the formulas that we've been employing up to this point because of the fact that most of those just involve, two subsets. There's three subsets here. So I'm going to have to make even more use of my Venn diagram and kind of do some things I did back in the previous chapter. So when I set this up, I'm going to have a Venn diagram set up here. I'm going to let L stand for lack of parental support. N is going to stand for neglected children or abused children. So that's the group, neglected and abused. And P is going to be for malnutrition and poor health being issues. And I start my way with the most restrictive out. I know there's 40 people that said that all three of these were problems. So that middle region right there is going to be 40. These, I'm getting these from carrying out the fact that there's 40 in all three parts of each group. So when I say there's 120 that think that the two problems are lack of parental support and abused and neglected children, that's including the 40 that's in all three. So I got to exclude those and carry out these calculations as such. So that's how I get the numbers I have in those intersections of where there's only two regions, between them. And then, of course, the rest of them, I'm going to take the 900, the 890, and 680 and subtract away these numbers that have already come up in the previous thing. So that means I would have 710 out here, 670 in the region where N is, and 470 in the region of P that was left over. Although it's not very important for this particular problem, I could state that the universal outside of this would be 0. So that means that, every teacher that responded at least had one of these as a problem in their school. So so there weren't any that didn't say that these weren't problems and none of these were problems at their school. So basically the universal or my entire subset or my entire sample space is defined by being the region that's encompassed by these three circles. But I said that's not as relevant for what we need to do here, because what we're trying to figure out now is what the probability of me picking a teacher from this group that says that the lack of parental involvement or parental support is the only issue. So I'm looking for this, region right here, because those are the teachers that said that that is an issue, but didn't name the other ones as being issues. And that was the only one that they felt was a problem in their school. So as far as figuring out the probability goes, I would do 710 over 2140, and that's approximately equal to 0.3318.